found it useful throughout my life to have a collection of questions that are good for detecting bullshitters. And what do I mean by that? I think there's roughly two kinds of people. One kind of person has a very high standard for claiming to know something. This kind of person doesn't want to use the quadratic formula unless he knows how it's proven. This kind of person doesn't want to use the identity sine squared theta plus cosine squared theta equals 1 unless he knows where it comes from the definition of a circle. And this person doesn't spout things that he's heard unless he's verified him. This is the non-bullshitter. It's the kind of person that I get along with. Some people are bullshitters, and by that I mean they don't have a high standard of understanding before claiming to know something. This person will state facts that they don't really understand, use words, or repeat things they've heard on TV without verifying them, and often you want to know when someone claims to know something like trigonometry, do they really understand it deeply, or are they a bullshitter who's just parroting some things back to you? So for instance, if you want to check whether someone really understands trigonometry, one good example is to ask, why is the radian dimensionless? We've talked about that. So the bullshitter will just wave his hands and say something about like, oh, well, I mean, it has to be dimensionless because we plug it into sine or something. But the non-bullshitter will say the radian is defined as a ratio of arc length to radius, and the units of length cancel. So that's one way to detect bullshitters. I think I told you in Slack about my interview question for Python programmers to detect whether someone truly understands the Python language and uses a list comprehension, or if they just translate from another language. But anyway, that was a big introduction to the bullshit detection question I like to use for exponential functions. So you could ask someone, what is meant, what do you mean really, as precisely as we can say, what is meant by the number 2 raised to the power pi? If you raise any number to an irrational power, ask someone and really push them. Can you tell me precisely what that number means, either by describing an algorithm that I could use to generate as many decimal places in that number as I want, or by telling me a definition which picks out a specific number? And often people can't. If it were an easier question, like what is meant by 2 to the 3rd power, an integer power, then any 6th grader could tell you, well, that means 2 times 2 times 2, repeated 3 times, and assuming we've defined multiplication, this is a precise definition of 2 raised to some integer power. And similarly, maybe if you ask someone who's a bit more sophisticated what is meant by something like 2 to the negative n, where n is an integer, well, that just means we divide, since a negative power is just the reciprocal. So we know what multiplication means, so you can multiply the number 2 together n times. So this dot 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 is supposed to repeat n times. So we know how to precisely define, assuming multiplication is defined, we can precisely define 2 to a negative integer power. And if someone's really clever, and you say, what about rational numbers? What about 2 to the power p over q? Well, they might figure out that if p and q are integers, this just really means raise 2 to the pth power, and then take the qth root, because we can use that power to a power rule. So assuming you've defined 2 raised to integer powers, which we've done here, positive and negative integers, and you know what a qth root is if you defined a qth root, then you can rigorously define a number raised to any rational power. But the trouble comes with an irrational number. So if you ask someone what they mean by 2 to the pi and they're a bullshitter, they'll usually say something like, well, you plug it into a calculator and it gives you some number. I mean, you just pick some decimals in pi is 3.14159, raise 2 to that power or something. But that's not enough for us. I mean, one of the goals of this group is to hold ourselves to the higher standard of the non-bullshitter. So in the next couple of videos, we're going to think carefully about what we mean by raising numbers to irrational powers, which will allow us to define exponential functions like f of x equals 2 to the x carefully on the entire domain of the reals. And there's several ways to define that work. We're going to use one for now, which is not totally satisfactory, but we'll have to revisit later once we have some technology from limits and derivatives to kind of flesh out the definition. Okay, so that's the goal. That's the end of this video.